Hello, class. Let's go ahead and take a look at your bell work. Okay, we looked at which are like terms. Now, it's been a while since we dealt with X's and Y's, but what I hope we noticed is that we have some numbers that are by themselves, we have some X's, and we have some Y's. Now, when we say alike, those are what we're talking about. Okay, so when we have two numbers that are alike, we are allowed to add or subtract them together depending on their sign. So if I start with 5 right here, 5 has no variable. So the only other number here that has no variable is this subtract 4. So I'm allowed to put those two together and say 5 subtract 4 gives me 1. Next, I'm going to go ahead and I'm going to look at this 2y. I'm using a box because it's not like this one. It's different. This one has a y that's being multiplied to a coefficient of 2. So are there any other y's here? Yes. So 2y and subtract 3y are alike. Now we can go ahead and put those together. So if we take 2 minus 3, we get negative 1 y's. Now what's left over is we do have 7x and 2x. They both have x's. So we're allowed to put those together. We have 7 plus 2 gives me 9 x's. Now when we get to this point in our expression, I have a number, a y, and an x. I cannot put these together. That means I am done simplifying my answer. That's my final answer. Now we're familiar with that with letters, but what happens when I start looking at square roots? Look at these numbers here and try to see which ones we might think of as alike. Good. These square roots behave just like the x's and y's. If the square roots are the same, they are alike. So we would take this 2 square root 3. Well, this one doesn't have a square root 3. This one doesn't have a square root 3. This does have a square root 3. Those two are alike because they have the same square root. That means we are allowed to add those together. So we're going to take the coefficients 2 and 3 and add those together to get 5 square roots of 3. Okay, there were 2 of them here, plus 3 of them here. So now we have 5 square roots of 3. And that works the same thing right here. We have 4 square roots of 2, and we have minus 2 square roots of 2. Because they are both square roots of 2, I am allowed to put those together because they are alike. So we're going to go ahead and do what it says. 4 minus 2 gives me 2 square roots of 2. Now, in between here, we're going to go ahead and keep what we've been doing and put a plus sign in between them. Now, we have square roots of 3 and we have square roots of 2. Those are not alike, so I cannot add them together. So this would be my final answer. Okay, let's see if you've got the idea of like terms. Let's take a look at this one. 2 square roots of 5 plus 4 square roots of 5. Go ahead and try it. Okay, what you should have done was taken the coefficients 2 and 4, added them together to get 6. Now in the square root, we're not going to add 5 and 5 is 10. No, we're going to say that there's 2 of them here plus 4 of them here and leave it so that we have 6 square roots of 5. All right, well, that's all well and good. What if we have a problem like this? The square root of 3 minus 3 square roots of 3. Well, first, what we need to notice that there's a missing coefficient out in front here. We have ourselves a hidden 1. Okay, and so this time we are subtracting. They are like terms because they're both square roots of 3. So we're going to go ahead and do 1 minus 3, and that's going to give me a negative 2 square root of 3. Okay, it's okay to add and subtract those coefficients with the rules that we already know. Now, let's go to a very interesting what-if problem. We have 2 square roots of 12 plus 2 square roots of 3. When we first look at this, it looks like these are not like terms and we cannot add them. However, I know that the square root of 12 can be simplified. So sometimes we're going to need to take a look at these right here and see if we can simplify it. Okay, so here we go, simplifying with our factor tree to see if 12, if I can get anything out of that square root. Now, 12 divides by 2 and gives me 6. 6 divides by 2 and gives me 3, and that's the end. Now look, we can factor out a double 2. So when I rewrite this, on the outside, I have 2, because there was already one here. And I'm going to pull out another 2. And what's left over inside the square root is a 3. So I have 4 square roots of 3. Oh, wait a minute. If this is a square root of 3 and this is a square root of 3, they are like terms. I just had to simplify before I could figure that out. So I can add 4 square roots of 3 plus 2 square roots of 3. I can add those together. 2 plus 4 is 6, and they have the same square root of 3. So sometimes when you're adding, you have to be very careful to make sure that you've simplified any numbers that can be before you check if they're alike or not. Okay, well, that being said, let's look at one more problem together. We have this problem, 3 square roots of 2 plus square root of 24 plus 2 square roots of 18. Right now, it looks like they're not like terms, but they might be if we simplify. Now, I know that 2 does not have any factors because I can't divide it by anything. So we'll leave this guy alone. But I am going to simplify the next term in our expression. We're going to see if 24 can be factored. 24 divides by 2 and gives me 12. 12 divides by 2 and gives me 6. 6 divides by 2 and gives me 3. So what I'm going to do for this answer right here is I'm going to take out a double 2 to the outside, and then on the inside I have to leave the lonely 2 and the lonely 3. So my simplified answer for this term is 2 square root 6. Okay? Now let's go ahead and take a look at our third term, and let's simplify that one and see what that turns into. Okay, I'm going to take 18, divide it by 2, and I get 9. 9 does not divide by 2, but it does divide by 3 and give me 3. So when I simplify this answer, I already have a 2 on the outside, and I can bring out a pair of 3s. And what's left over is a 2. All right, let's clean that up just a little bit. 2 times 3 is 6. And we have a square root of 2. Now, let's look at all 3 terms. I'm going to go ahead and bring this guy down here. We have 3 square roots of 2, 2 square roots of 6, and 6 square roots of 2. Are any of those alike? Yes, we have 3 square roots of 2 and 6 square roots of 2. This one is not alike. So what we're going to do is we're going to go ahead and add together the numbers that are alike. So 3 plus 6 gives me 9 square roots of 2. This one we weren't able to add it to anything, so we'll just write it down as part of our answer. And there we have it. We've combined all of the square roots of 2, written down what can't be combined, and we have our final answer. Now your mission today is on the back of the page. We have some addition and subtraction problems that you are going to need to put together with the like terms. Sometimes you will need to do the factor tree and find out exactly what that answer is first before you decide if it's alike. All right, good luck and have a great day.